Hey there, welcome back to the channel. Today I have the long-awaited follow-up to my 4L60E autopsy comeback, no 3-4 shortly after rebuild video, and I'm very happy to say that I have identified the problem. And I'll say right off the bat that it had nothing to do with the transmission. It affected the transmission, it directly impacted the transmission's ability to function properly, but the cause was outside or off board of the transmission. So in essence, there is nothing that I did either procedurally or through part selection choices or build judgment calls, if you will, that led to that particular failure. So what we're going to do is kind of go through a methodical testing of all the components that would have a role to play in a 3-4 failure shortly after rebuild, including the forward drum, the valve body, the pump cover stator support, which is over on the Sonic's vac test bench, and the case itself. And I'll walk you through some of the things that you always want to check for on disassembly, and even after the parts have all been cleaned up and you put back together with the valve body and the stator support and forward drum. Alright, so what we'll do is I'll start with the forward drum. We'll go ahead and we'll do a pressure test. It's fully assembled, has all new clutches and new steels. Everything's been rebuilt. This transmission is actually going to go back together today, in fact, and go out the door sometime next week. But I didn't want to do anything with this thing until I got to the bottom of that failure, because I wanted to make sure that it wasn't due to one of these parts or some other part within inside the unit that is defective in a way that's not readily obvious. So anyway, we're going to start with the forward drum. And we have our, in fact, let me reposition the camera here, sorry. Alright, we have our fluid here at the base, and we're going to go ahead and put a little bit of air to see if there are any bubbles. Now, I already did this, and there was no bubbles. It tested negative for leaks at the drum. Alright, so I'm now going to put air in the 2-3 feed. Okay, nothing. Okay, everything's good. So now we'll do the forward. So here's forward. Okay, hear all that trapped air whooshing out. So what I'm doing is I'm pressing on the trigger, and then I'm gonna let it go, but I'm not gonna take the nozzle off. Okay, that's what you want. You want a clutch circuit that is sealing such that after you've taken your trigger finger off, but you've not removed the nozzle, the air is staying trapped inside that cavity. In this case, it would be the forward piston and piston housing. So now we're going to go ahead and we'll do the coast clutch, and you want to plug the forward feed hole. And air is literally trying to push my finger off the forward feed hole. So that's how you could tell you have a healthy drum. Now, I will say this. Between the time I filmed that initial autopsy video and now, a viewer, and I don't know if this person's a subscriber or not, but a viewer made me aware of another transmission channel that has started to test these drums at operating temperature. So what he's doing is he's taking a big pot, he's sticking the forward drum in the pot, and he's pouring transmission fluid up to about here, I think, and he's putting all this on a hot plate and heating it up to about 175 to 200 degrees, somewhere in there. And then what he is doing is he is taking some of that hot fluid, pouring that fluid right in this cavity, and he's doing a pressure test hot. And he has observed, and he discusses this in the video, he's observed that drums would pass when they were tested at room temperature, but they would fail under the hot test. Okay, that's very interesting. So I want to make sure I give credit to both the viewer and to the transmission channel that has the video showing this. So I'm going to do a video myself, and I have like several drums. I'm going to just build them all up with, just used frictions or whatever. I mean, it doesn't really matter just for the purposes of testing. And I'm going to see if I have any drums that check good cold and fail hot after heating them up to about 175 to 200 degrees, which is typical operating temperature for 4L60E transmissions. So this drum is good. There was no issues whatsoever. There was a commenter on that video that said the reason why this failed, or at least this is what he opined, or this is what he advanced, the reason why this clutch failed was because I used different brand of frictions in the 3/4 pack. Different, I think one was Borg-Warner, and then the rest were Alto or something like that. I want to be the first to tell you, and I want to make sure this is, crystal clear and understood as fully as possible. That is 100% false. Okay, if somebody tells you that a clutch in an automatic transmission will fail because different brands of friction disc were used in that particular clutch pack, that is wrong. Okay, that is not a thing. I've been mixing and matching frictions in this and many other transmissions to either get clearance or because that's all I had, or for whatever reason, for years. As long as I've been building transmissions, which is now going on 11 years. All right, maybe not the 25 or 30 year careers you see with some builders on YouTube and elsewhere, but 10 years and thousands of transmissions. I've never ever had one come back because of mixing and matching different brands or manufacturers of friction, as long as it's for that particular transmission. Okay, as long as the friction disc is formulated for the same transmission fluid, or designed for the same transmission fluid, when in the case of 4L60E 700R4s it's Dexmerk, you'll never have a problem. So if you have 3 frictions made by Alto, 2 frictions made by Borg-Warner, and let's just say a friction made by Exity and a friction made by All-O-Matic, and you were running a 7 clutch stack up in whatever transmission, it'll be perfectly fine as long as the clutch itself is set up correctly. So if anybody tries to tell you that, you know immediately that they don't know what the hell they're talking about. Alright, that is the forward drum. So now I'm going to move on to the case itself, and I'm going to reposition the camera to do this, but what we're going to do is we are going to test the third accumulator check ball capsule for leaks. So here's our servo board, and here in this location is going to be our third accumulator check ball capsule. Okay, I have to reposition the camera. In fact, I'm going to have to reposition it a couple of times because I want to make sure that you see what I'm going to do here if you don't already know. If you already know where this is going, but if you don't, this is an essential test you want to perform. And what we're going to do is test the sealing of the check ball when it's fully seated, and sealing against the capsule itself. Because what happens there is when this transmission shifts from 2 to 3, that check ball seats. Okay? And fluid comes in front of the servo, pushing it off. Okay? Pushing it off the band, and additional fluid goes to the 3/4 clutch pack underneath that piston to apply that clutch. So it's a timing, a band release, and application of the 3/4 clutch pack that gives you that shift from 2 to 3, okay, from second gear to third gear. If this ball capsule is leaking, you're not going to have a smooth and normal transition between second and third gear, okay? You're going to have either bind-ups or flare shifting, or both, depending on how bad it's leaking and the individual transmission and whatever. But the bottom line is you need to make sure this ball capsule is not leaking. And I will tell you, and this will be the last thing I say before we actually do the test, I will tell you that of all the transmissions I've done, as well as all the builders that regularly do 4L60E 700R4s, it's very, very rare to have this actually leak. Most of the time, it's a little bit of crud or contaminant, material or whatever that gets up in there between the seat and the ball, causing it to leak, a very slight amount. I mean, it'll still cause a problem if there's a lot of, built up detritus. And the point is, when you shoot a little bit of brake cleaner in here and retest, chances are that check ball will seat and seal completely. Alright, so now what I'm going to do is reposition the camera, and I'm going to put you right in front of the case bore. And what we're going to do is we're going to turn the case belly up, and I'm going to pour a mixture of acetone and transmission fluid into this little cavity here, and then we're going to see if any fluid or leakage, appears into the case. A whole bunch of it's going to come into the servo bore, but nothing should be leaking into the case. It should be bone dry when we're doing this. Okay, so right here is where we're going to focus our attention. We're going to see if anything leaks. Alright, so I'm going to go ahead and pour some fluid. Back here, I'll back it off so you can actually see me do that. And then we'll zoom in on that area. So right there. We'll take a fresh shop towel, and I'm just going to run it along the inner case wall. Bone dry. Let me get this valve body out of the way a little bit more. So right there is the ball capsule in question. As you can see, there's fluid and whatnot pouring into the servo bore, and that's perfectly fine. What you don't want to see happening is fluid trickling into the case, because that would be indicative of a leaking third accumulator check ball capsule. Now, if the ball capsule is leaking and you flushed it out with brake cleaner, dried it off and retested, it still leaks, then all you really need to do is pull the ball capsule out and put a new one in. And probably the most cost-effective way to yank these out is just to simply take an appropriately sized bolt that's long enough and cut little slits vertically into the threads to make what's, I guess, an improvised easy out. Thread it into the mouth of the capsule, and then use a slide hammer to wrap it out. And then from there, just use an appropriately sized drift punch to install the new one. Now, they do make special tools for these, and I have them, but I honestly don't remember the last time I used them. That is how rare this condition is. So I know that there's always a lot of chatter on forums when it comes to this particular ball capsule and how it could leak, but if you talk to any transmission builder that's well versed in these units or 700R4s, they'll tell you that it's something they see only once in a blue moon. Alright, next thing we're going to do is go over to the Sonex vac test station, and we're going to test that pump cover, your stator support. We have valves installed, the same valves that were in this transmission from the, to begin with, and then we're going to test the valve body that you see over there. That valve body, I didn't take it apart yet. It's as it was when I took it off the case, as you saw in that video. So let's go over there and we'll do some testing. Alright, so first I'm going to test the valves and the pump cover, and then we'll put the valve body here and we'll test that. So first things first, I want to make sure that our machine's calibrated so that our readings are relevant and usable. So what we want to do is stick the lead or hose that's coming off your test fitting here on the machine and put it right in the calibration receptacle, and then turn the machine on. Alright, what you want to see is 5 inches of lift, and that's what we have. Next, you're going to take your finger and stick it on the calibration port on the side of the machine and validate that you have 25 inches of lift, which is what we have. Take it away, should go right back down to 5. If you need to, make little adjustments. Should go right back up to 25. And it takes sometimes a few iterations of this to get it just right. Looks like I'm slightly off, so I'm going to adjust my bleeder valve. Okay. I'm satisfied now that the machine's ready for testing. So, if you watch my 4L60E pump stator testing video, this is going to be a carbon copy of that. And so just grab your test block, stick your test lead or hose into the block, and have your gasket ready. Now, a couple things before we begin. I have a Sonex torque converter apply valve standing by. It has a little Teflon sealing ring, so in the event our factory valve is not sealing adequately, we have that ready to go. Installed is a Sonex boost valve. It's a 4L60E LB1. It is for an early model unit. This is a 2001 model year unit, so you want to use the early model. Now, as I mentioned in other videos, the Sonex HP1 Performance Pack only gives you the late model, but they also give you a little spacer that you install right underneath the snap ring for the early model designs, or the stators that take the early model boost valve assembly, and that will allow you to run those in that late model version in an early model pump cover. So when we get to the valve body, in the event the actuator feed limit valve is worn, we have a central valve body's oversized AFL valve. It's a drop-in valve, no machining required. And these are oversized by 1/1000th of an inch over the factory valve. And that's usually sufficient to bring you back where you need to be. If it needs more work than that, you're still beneath 15 inches of lift, then at that point you'll need to ream that valve body or replace it with one that doesn't fail, or at least fail this test. Alright, so here is where we're going to test. We're going to test the inboard side of the apply valve, as well as the outboard side. When we test the outboard side, we have to seal off the port down here. Okay, seal this off, and then we have to push with our finger, push the valve inboard. Okay, because if you don't do that, you're going to get a artificially low reading there. And if you don't put your finger, you're not going to get anything. Okay, then we're going to take a reading on the pressure regulator valve inboard. That's this location right here by my thumb. And when you do this, you have to make sure that you have the little orifice in the valve itself accessible to you, because you're going to take a pencil with an eraser and plug it. Otherwise, it's only going to draw about maybe 3 to 5 inches of lift, and again, it'll be reading artificially low. Alright, last we're going to test the sealing integrity of the boost valve location. So that's this circuit right here. And then we got to plug a hole underneath so that it's not, emptying the vacuum out the bottom of it. Alright, let's begin. Trying to get this in the shot to the extent I can so you can see what I'm doing. Alright, 15. 15 is good. Okay, now we're going to head and go test this circuit here. You want to make sure that you have the entire circuit covered. Alright, so remember what I was saying. If I don't push the valve inboard with my finger, I'm going to be a little low on my reading. So let me go ahead and do that. Okay, now I'm at 16. I'm not pushing it in, it drops down to, looks like 14. Okay, and it's dropping a little bit more. So you want to make sure that you push that valve in, otherwise you'll have an artificially low reading. Alright, here is the pressure regulator valve. Okay, it's going to draw a little bit of vacuum. Like I said, 3, 4, maybe 5 inches. The amount of vacuum it draws without you plugging this little orifice in the valve itself is irrelevant. Okay, we're sitting at 16 and a half. That's good. Okay, it's back down to, looks like 3. I'll go back up with it. And you have to apply a little bit of downward pressure to make sure you seal off this little pinhole completely, otherwise it'll bleed off. Alright, last we have our boost valve. Okay, make sure you cover this entire circuit or entire channel. Okay, we are sitting at 25 inches of lift, which is to be expected given we have the Sonic's boost valve, which has an O-ring, or actually a pair of O-rings on it. So if you're getting something like 15 with a Sonic's boost valve installed, then chances are you cut one or both of the O-rings either partially or completely, because the outer diameter of the sleeve is the same diameter as the stock valve with no O-rings. So it'll still seal, but it won't seal completely. So that's how you know if you cut an O-ring, is when you put it on the test machine, it'll show something like 15 or 16 or maybe even less than that, and who knows. But it should be 24 to 25 inches, which is a complete and total seal if you installed them correctly without damaging either of them. Alright, let me go and grab the valve body. Okay, so like I said, this was not yet disassembled. So the two valves of concern to us are going to be the actuator feed limit valve and the torque converter clutch regulator valve. All right, most of the rest of the valve trains in these valve bodies are usually okay. I mean, every once in a while you'll see a poorly sealing bore plug, like for example either the forward or the reverse abuse bore plug. We had that when I did the filming of the other 4L60E valve body, the 2010 model year unit with the test plate. We saw that. So I'm just going to use the test block for now because it takes a minute to set up that stupid plate, and I'm not trying to take a minute. I mean, I'll do it later, but it's not like you haven't seen it before. Alright, so here's our AFL location where we want to test. Alright, 15. 15 is perfectly fine. Alright, you're going to need to exert a little bit of downward force on this thing. Alright, next is the torque converter clutch regulator valve. So this has a transgo kit. I mean, I'll test it here, but I don't know how valid this reading is going to be, given that there's just a spring there. There's nothing inboard. Okay, so it's actually going to test the entire circuit inboard of the valve, as well as regardless if there's a spring in there or not. All right, so now I'm going to test the TCC regulator valve. Now this has the transgo shift kit in it, so there's the blue spring and then the transgo valve in here. So this is the location that you want to put your test block. It's like 15, 15 and a quarter, 15 and a half. That's perfectly fine. So this valve body's healthy. These solenoids have literally about 200 miles on them, so they're brand new. And the valve body is clean. So I'm probably just going to install it like this. There's no reason not to. Like I said, the failure has nothing to do with anything on the transmission. So let's go back to the bench and we'll talk through what actually happened, what caused this, no 3-4 or neutral 3-4 shortly after rebuild, so that we can kind of fully unpack everything that went on and that transpired, and also take away some lessons learned, especially for me. So I'll meet you back at the bench. So what caused this problem? What happened? We know that there was nothing in the transmission itself, whether through assembly procedures or defective parts or wrong parts, that caused this no 3-4 shortly after rebuild. So what happened to lead to this situation whereby the transmission had to come back out? And in this particular customer's case, I had decided to rebuild an entirely different 4L60E for him, because he's located a bit away from me, so that he didn't have to make multiple trips. So I built a whole nother core out of my stack of cores, set it up pretty much the same configuration, and on top of it I gave him upgraded clutch module, the Alto high energies everywhere, along with a max pack in the 3-4, which he did not have initially. He just had a standard 7 clutch stack up, and I say standard because it's not that much different than the 6 clutch factory packs. So here's what happened, and for those of you that have experience in this, you probably already figured out long before I even started talking. As soon as you saw the thumbnail, you said, yep, that's it. So what is it? It's this thing right here. Okay, this is a 4x4 unit. Okay, the customer has a 4x4 Toyota 4Runner, and it's used for, towing, hauling, off-road, and just normal daily driving. So what the customer had done was that a part of his general maintenance and overhaul and, kind of work he was doing to the powertrain at the time, he replaced the speed sensor in the transfer case with another speed sensor. Okay. Now, fortunately for everybody, he did not throw out the speed sensor that he took out of there. He kept it aside, which was very smart. Okay, for a variety of reasons. But he wanted to just simply replace stuff because it was old, right? Just part of regular scheduled maintenance. And what he did is he purchased an OEM equivalent speed sensor, just like the one in this box. Okay, this is an OEM equivalent speed sensor for an MP246 transfer case for a 2003, 4, and 5 Chevy Tahoe, GMC Yukon, Silverado, Sierra, anything that took this general powertrain, 4L60E MP246, or RPO code MP8. What occurred was this. With the installation of this aftermarket speed sensor, it functioned for a while, a couple hundred miles, and then it started to intermittently fail. And it was failing in such a way that it would work for part of the drive cycle until after X amount of miles, and then it would start to fail. It would not generate the requisite voltage that the PCM was looking for to translate that voltage signal into a vehicle speed. So for all transmissions that are electronically governed and controlled, and this is, as far as I know, it's universal. Doesn't matter, make, model, country of origin, manufacturer, just does not matter. If the vehicle speed sensor either fails or the voltage signal from the vehicle speed sensor is not being received for whatever reason by the powertrain control module, the transmission will default to first gear, and all upshifts and adapts will be frozen, simply because the PCM has absolutely no idea how fast the vehicle is moving. So all it's going to allow is first gear. It'll lock out everything else. And so when you're traveling at 25, 30, 35 miles an hour, around the time where you're transitioning from second to third gear, and this happens, the signal, the voltage stream is interrupted, then it's going to mechanically backshift to first, and it's going to feel like you're in neutral. So from the point of view of the driver, that's going to appear indistinguishable from a mechanical failure inside the transmission, specifically the 3/4 clutch pack. So you have line pressure, you have apply pressure going to both the forward piston and the third clutch piston, and solenoids A and B are both off. As soon as that PCM realizes it no longer has a true voltage signal from the vehicle speed sensor, bam! It turns solenoid A back on and mechanically backshifts you to first gear. So that's what happened. And the reason we know that is because the customer called me up. He called me up about a week ago or so now, as of the filming of this. And he said, hey, I want to go over something with you. And I said, sure. And he started talking, and he kind of relayed to me all of the investigative work that he found. And it turns out that when he put my replacement transmission in the vehicle, it had the exact same symptoms, neutral and third. After driving for a while, everything hot, warmed up at operating temperature, whatever, it started to do the same things. And he said to himself, okay, what are the chances that Nick's going to build two bad transmissions? Okay. Fortunately for him, he reasoned that it was not very likely, and he started to kind of go back through the diagnostic progressions, and he came to the speed sensor, and he says, let me see if anything changes if I put this old speed sensor back in. He put the speed sensor back in, and sure enough, the problem resolved. He put, I think, I want to say a couple hundred miles on it, since he went back to the original speed sensor, and there's been no reoccurrence. And to this day, I have not heard back from him at all as far as any reoccurrence of problems or issues. So, the moral of the story here is that never, ever, ever use aftermarket electronic components in your vehicle. Doesn't matter what it is, transmission stuff, engine, ABS sensors, whatever. If it's electronic or electrical in nature, and it's not OEM or not from a trusted manufacturer such as Rostra in the case of transmissions, do not use it, do not install it, do not buy it. That includes all the stuff from your I don't want to call them big box auto parts stores, but all the usual O'Reilly's, AutoZone, Advanced Auto, CarQuest, whatever. An overwhelming majority of the stuff that they're going to sell you when it comes to the electronics is garbage. Okay, same with Amazon. Be real careful about what you buy on Amazon. I bought that on Amazon. Okay, this I purchased on Amazon for the same price as an OEM speed sensor, by the way. Now, I've never installed this one. I'm not going to. I literally purchased it just for the sake of having it to make a point, as part of the filming of this video. So, never buy aftermarket stuff. Now, the other lesson learned for me is that I should have had him go through the diagnostic progressions, and it should have occurred to me that this problem, or at least the way it presents, could be sourced to an electrical issue as just as likely, if not more likely, than a mechanical one. Because what I basically said was, okay, let me rebuild it because I screwed up. It's like I already admitted defeat before I had him go through the progressions, and it cost him some time and money pulling it out and getting it down here, and exchanging and putting the new one back in. So, that all could have been avoided if I had asked him to test that speed sensor. Okay, and the only way we would have been able to test it is if he had his other speed sensor, which he fortunately happened to have. So, anyway, I also want to take a moment to recognize this customer for his integrity. I would have never have known that this particular, that particular speed sensor was the root of the problem if he had not contacted me, and he could have by rights said nothing at all. But he didn't. He called me back. and he said, "Hey, I found the problem, and it wasn't your transmission. It was this aftermarket speed sensor." And you know, it's kind of vindicating, because here I'm thinking, man, I screwed up in some way, or didn't catch something, or there was something that I should have done differently, or you start going through kind of all these mental gyrations when something like this happens, and you begin questioning your work and your ability to even do the work. And some of that was going through my mind. Now, I built 4 or 5 4L60Es since, and none of them have any problems thus far. Here we're talking the total time span that's relevant to this video is about 3 months. But point is that you can begin to question yourself, and that should never be. Okay, I should have 100% confidence in my ability to build a transmission, especially a 4L60E, which I do on a matter of 7 to 1, 8 to 1, compared to all other transmissions combined. So anyway, I wanted to close the loop on this. I wanted to provide an update, and most importantly, I wanted to share what we had found together, the customer and I, so that you are aware of it in the event it's not something you consider in the event this happens to you. So thank you so much for watching. We'll catch you on the next one. Take care, have a great rest of your day or evening, and we'll see you then.